Is my screen visible?
Yes.
Okay, so in this scenario, let's say PC1 have one IP address 10.1.1.1, PC2 have one IP address 10.1.1.2. Fine. Let's say PC1 MAC address is A and PC2 MAC address is B. Guys, try to understand here in this scenario problem very carefully, right? If you will understand the need of a spanning tree protocol, then only I can make you understand what is a spanning tree protocol. And as I told you, a spanning tree protocol is heart of switching, very important protocol of switching. So in this scenario, if 10.1 want to communicate with 10.2, can anyone tell me the process? In this scenario, 10.1 want to communicate with 10.2. 10.1 need what? 10.1 need what? MAC address of 10.2 first. Yes or no?
Yes.
For that, 10.1 means PC1 will generate what? ARP request message. Right, guys?
Yes.
PC1 will generate ARP request message. In the ARP, source IP will be what? 10.1.1.1. Destination IP will be what? 10.1.1.2. Source MAC will be what? A, and destination MAC will be what? All F broadcast. Yes or no?
Yes.
And when switch 2 will receive this broadcast frame on F0/3, what switch 2 will do first of all?
It will add that source MAC address.
It will learn the source MAC address.
Yes.
Right? Means it will make one entry in their MAC address table. It will make one entry in their MAC address table that a device is connected on 0/3 interface whose MAC address is A. After that, switch 2 will forward one copy from this interface and one copy from this interface, because switch will look up their MAC address table, but in their MAC address table, in this scenario, frame is broadcast, right? Destination is broadcast. So this is broadcast frame, so switch will forward one copy from this interface and one copy from this interface, right? Switch 1 will learn a MAC address on which interface? 0/1. Right?
Yes.
Okay. After some time, when switch 3 will receive broadcast message on this interface, switch 3 will also learn a MAC address on 0/2 interface, and switch 3 will forward this broadcast message from here and here. Yes or no? So again, switch 1 will receive broadcast message on this interface, right? So this time switch is learning same a MAC address on which interface? On 0/2 interface. It is learning same MAC address A. So switch 1 will flush this entry. Getting my point? And then switch 1 will forward that broadcast message to switch 2. Again, switch 2 is learning a MAC address on which interface? 0/1 interface. It will remove this entry and it will make one new entry, a MAC address on 0/1 interface. Again, switch 2 will forward this broadcast message from this interface. Switch 2 will learn a MAC address on which interface? 0/2, and switch 3 will receive broadcast message from switch 1 also. So switch 3 will also flap MAC address A from 0/2 to 0/1. So MAC address table of all switches are flapping in this scenario. Yes or no? MAC address table of all switches are flapping between two interfaces. Switch 1 is learning a MAC address on this interface. Soon it is learning a MAC address on this interface. Same thing is happening on switch 2 also. Same thing is happening on switch 3 also, right? So whenever a user will generate a broadcast message, right? Here what is happening? Broadcast traffic is also moving here, right? Broadcast traffic is also moving. That means we have one loop here in the topology. In the switching network, right? This is how loop can form. So whenever we will connect topology or devices in a circular, right, in a loop, then whenever a user will generate broadcast traffic, loop will form in the topology and MAC address table of switches will start flapping. Loop means nothing. MAC flapping. MAC flapping is called loop in the switching network. Let's say same thing will happen if I have two switch 1 and switch 2. For redundancy purpose, let's say I have connect two link between switch 1 and switch 2. Again, if some user will generate broadcast message, right here loop will form. Yes or no? We can check it practically also, like in packet tracer. If I will design same topology like this, here if I will design same topology, let's say switch 1, switch 2, switch 3, and let's say I have one computer here and I have one another computer here, right? These all devices are connected like this. This topology is visible, or should I zoom it? Now it is visible. And see guys,
Yes.
I have connected the device, but see the LED ports are not up because of a spanning tree protocol. These ports are not up. These ports will come in forwarding state after 30 seconds. So in a spanning tree protocol, you will understand this, right? Why port is taking 30 seconds to come in forwarding state. But now you can see ports have come in forwarding state, but still two ports are not in forwarding state. And now you can see topology is stable, but this port is in what? Blocking state. This port is in blocking state. So here loop will form? No, because my logical topology is this one: switch, switch, and switch. Here we have one cable, here we have cable. This cable is not working. So either I can run STP protocol here, or manually I can assign one network engineer here that whenever this path or this path will goes down, you will put the cable, and if this path and this cable is up, you should unplug the cable to avoid the loop. Or here automatically a spanning tree protocol is doing same work, like plugging the cable, unplugging the cable. If let's say this link will goes down, automatically a spanning tree protocol will plug this cable, right? Now this port is block. So what I am going to do here, I am going to disable a spanning tree protocol on all switches. By default, a spanning tree protocol is enabled, right? So if I will disable a spanning tree protocol, then what will happen? All ports will come in forwarding state. Then loop can form. Then loop can form in the topology. Whenever we have redundant path, right? Whenever we have redundant path in switching network, right? We need a protocol who will be responsible to avoid loop, or I need an engineer for unplugging the cable and plugging the cable, right, to avoid loop. Because in this scenario also, if I want to avoid the loop, what I can do, I can unplug either this cable, I can unplug this cable, or this cable. I can unplug any cable, right? So that my topology will be in like this, not in loop. So if physical topology is not in loop, then loop will not form. Definitely then loop will not form. But if my physical topology is in loop, then definitely loop will form. But if let's say here I don't have any cable here, right, between switch 1 and let's say switch 2, then what will happen? What the problem is there? Problem is there. We don't have redundant path. Let's say here is one user, here is one user. These two users are communicating with each other. But when this link will goes down, right, now there is no any alternate path available, so we don't have redundancy. So if I will connect one more cable here for redundancy, automatically loop will form here, right? So either I can assign one engineer for unplugging the cable and plugging the cable, or I can run protocol like STP to avoid the loop. Like you can see in packet tracer what a spanning tree protocol is doing. Same thing a spanning tree protocol is doing here. A spanning tree protocol have blocked this interface, and it have designed loop free topology like this. Right? So see guys, in this scenario, if I will disable the spanning tree protocol, first of all I am going to disable a spanning tree protocol on switch number 1. So see, simply we need to run one command. By default, so a spanning tree protocol, you can see a spanning tree protocol is running, right? This port is in forwarding state, and 0/3 is in blocking state, as you can see here, right? Now I am going to say to this switch, no spanning tree for VLAN 1. No spanning tree for VLAN 1. Now you can see both ports of this switch comes in forwarding state. Now this port is blocked. Now STP protocol have blocked this interface. Now I am going to disable spanning tree protocol on switch number 2 also. Here also I am going to run same command, no spanning tree for VLAN 1, because by default we have only one VLAN. Say no spanning tree for VLAN 1. Now you can see again these two ports come in forwarding state. Now this port is blocked by STP. So here also I am going to disable spanning tree protocol. Say no spanning tree for VLAN 1. Now you can see all ports are in forwarding state. Now if any switch will receive broadcast traffic, right, you will see link will start blinking. Link will start blinking. These LED will start blinking, right? That means there is loop. So for that, what I am going to do, I am going to configure one IP address on this PC, so that once I will configure IP address, this PC will generate what? Gracious ARP to check duplicate IP address, yes or no? And Gracious ARP is a broadcast message. So on switch 1 will receive broadcast message, right? It will forward to both switch 0 and switch 2, and loop will form here, right? So let me show you. IP 10.1.1.1 subnet mask this one, and see all links started blinking, yes or no? So now we have loop in the topology. How to verify the loop? So you can check the MAC address of PC1 and see what is the MAC address of this PC0. In last it's 0C. In last it's 0C, and now I'm going to show you MAC address table of any switch. Let's say MAC address table of switch 0. So MAC address table. So see, this MAC address, which is learning this MAC address on which interface? On 0/1 interface. Now this MAC address is on which interface? 0/2 interface. Now after some time it will learn same MAC address on which interface? 0/1 interface. So you can see this MAC address is flapping between 0/1 and 0/2. Yes or no?
Yes. Yes.
So this is what? Loop. So to avoid this loop, we come up with protocol called STP, spanning tree protocol.
STP.
And by default, spanning tree protocol is enabled on switches. So here, if I will enable a spanning tree protocol, what a spanning tree protocol will do? It will block one link. It will block one link. So a spanning tree protocol is actually used to create loop-free topology. What a spanning tree protocol will do in this scenario, if I will enable a spanning tree protocol, STP, it will design logical topology. Logical topology can be like this, switch 1, switch 2, like this. Logical topology can be like this. Logical topology can be like this. Getting my point? So a spanning tree protocol will design any loop-free topology like this topology. Maybe a STP protocol will design this topology or this topology or this topology. And in this topology, loop will not form, right? In this topology, loop will not form, because let's say here we have one computer. If this computer will generate broadcast message, this switch will forward that broadcast message to this switch will forward it to this switch. Now this switch is not going to forward broadcast message back to this switch. Getting my point? So in STP, what we need to do, we need to learn that how a spanning tree protocol is going to design logical topology. How a spanning tree protocol will decide this port should be in blocking state or this port should be in blocking state, right? How STP will decide that, which port should be in blocking state. And guys, to avoid layer 3 loop, we have TTL, but you can see to avoid layer 2 loop, we don't have any mechanism like TTL. So loop is still there in the network. So this loop will be for lifetime here. To avoid this loop, either I can enable a spanning tree protocol or I can remove one cable. If I will remove this cable, automatically you can see now my topology is stable. Or I can enable a spanning tree protocol. Clear? Any question, guys, till here? Any question?
For load balancing and all, we can use that loop now.
For load balancing, we will understand how to achieve load balancing as well. But for now, just try to understand how we are going to avoid loop. For load balancing, we have Ether channel, right, to bundle multiple physical link into single logical link, and a spanning tree protocol will work on that logical link. Here, I am not achieving load balancing by connecting one cable here, right? This cable is not for load balancing. This cable is for redundancy purpose, for backup purpose.
I think this is for active and standby.
Yes, brother.
Yeah, I think this is for active and standby scenario, right?
Not active and standby scenario. That is also different thing. This is only for redundancy. I have connected this link for redundancy purpose, that whenever this link or this link will goes down, this link should be used for forward the traffic of user.
Okay, redundancy means that is active and standby.
Backup path.
Okay.
Backup path. Let's say this is location A, this is location B. I want to reach location B from location A. I have only one path, right, to reach here, right? And let's say this path on this road, this is road. Through this road, I can reach to B location from A location. But due to construction work, now this road is not working, right? This road is not in working state. So can I reach location B from location A? No. So I need what? One backup path also. One backup road should be there. Maybe that length of that road is larger, right? Or speed is slow. But we have at least backup path, that whenever this road will not work, I can reach to B location from A location by using this path, by using this road. For the same scenario here, I have used this link between switch 1 and switch 2 for redundancy purpose only.
Okay.
Any other question? We will discuss active standby scenario also later.
When STP enabled,
By default,
for example, enable switch 1 to switch 2, switch 3, sorry, switch 0 to switch 1,
okay.
The link was down.
Okay, so if you will manually shut down the link, manually shut down the link, STP will up this port.
Okay.
Automatically, a spanning tree protocol will sense that this link is now not in forwarding state. This link is not working, right? So STP will, maybe earlier STP was blocking this link. So STP will allow this link to forward traffic. Once any link will goes down. Same thing will happen in this scenario also. You can see this scenario. In this scenario also, when PC1 will generate broadcast traffic, PC1 will forward to switch 3. Switch 3 will learn MAC address of PC1 on this interface. After that, it will forward to switch 1 and switch 2. Switch 2 will again forward to switch 1. So switch 1 will learn MAC address of PC1 on this interface also, on this interface also, on this interface also, right? So this is MAC flapping and loop. So to avoid this loop, we come up with a spanning tree protocol, STP. So what is STP? STP is a layer 2 protocol which is used to avoid layer 2 loop. Now guys, to understand STP, first of all, we need to understand election, right? How switch is going to decide which port will be in blocking state and which ports will be in forwarding state. For that, out of these 3 switches, one switch will become root bridge switch. Out of these 3 switches, one switch will become root bridge. Root bridge is like master switch, like DR in the OSPF, like master in the OSPF. Right? So out of these 3 switch, one switch will become root bridge. So first of all, once I will enable STP protocol here, these switches will participate in root bridge election. These switches will participate in root bridge election with the help of hello message, and hello message of STP is called BPDU message, BPDU. So once you will enable a spanning tree protocol, switches will start sending BPDU message. BPDU is nothing but like hello message of OSPF. Bridge protocol data unit. Bridge protocol data unit. This is a message of a spanning tree protocol. So switch 1 will send BPDU to switch 2, switch to switch 3 also. Switch 2 will also share their BPDU to switch 1 and switch 3. Switch 3 will also share their BPDU to switch 2 and switch 1. Right? And then one switch will become root bridge switch. Now question is, which switch will become root bridge switch? Switch which will have lowest bridge ID. Switch which will have lowest bridge ID, that switch will become root bridge. Now question is, what is bridge ID? Now question is, what is bridge ID? So guys, bridge ID is combination of two things: priority plus MAC address. MAC address of switch, base MAC address of switch. Priority plus base MAC address. So leave this scenario. Let's come on this scenario. In this scenario, see, you are able to see MAC addresses of all switches, and by default priority on switches is 32768. Here also 32768. Here also 32768. Here also 32768. So what will be bridge ID of switch 1? 32768 plus base MAC address, this MAC address. What will be bridge ID of switch 3? Priority plus MAC address. Priority plus MAC address. Priority plus MAC address. So now you tell me which switch will become root bridge in this scenario.
Switch 1.
Switch 1, because priority is same on all switches and switch 1 have lowest MAC address. So switch 1 is going to become what? A root bridge in this scenario. What it's saying?
Means you are saying that the BPDU message or packet, it contains that MAC address and this priority, right?
What it's saying? This bridge is the root. This switch is root bridge, and all ports of root bridge will be in forwarding state. Here you can see. Any question in root bridge selection, guys?
No, in that BPDU message, actually what and all contents are there?
There will be many information. Let me tell you here. In BPDU, one BPDU is going to carry multiple information like there will be information about version. There will be version. There will be version of a spanning tree protocol. It will be 0x0000, I think, 2-byte information. We will see what is the version information. What will be the version information. After that, type field will be there. Type field will identify which type of message it is. See, there are two types of messages in in STP. There are two types of, you can say, BPDU. One is configuration BPDU and another one is TCN BPDU. So type field will identify which type of BPDU it is. Type field will be there. Flag field will be there. Flag 8 bits information, 8 flag are there, right? After that, root bridge information will be there. Root bridge ID. Root bridge ID will be there. Cost will be there. Cost information, designated port ID information will be there. After that, designated bridge ID information will be there. Here let me write designated bridge ID. Bridge ID information will be there in the BPDU. Then max age timer will be there, max age timer. After that message age will be there, message age. Then hello timer will be there, hello timer. That will be 2 seconds. Means after 2 seconds, root bridge will send BPDU. First time all switch will send BPDU. Let's say I have this topology: switch 1, switch 2, and switch 3. When these switches will come up, all switches will think what? I am root bridge. All switch will think I am root bridge. So all switches will generate their BPDU. All switches will generate their BPDU. Switch 2 and switch 3. Okay. Let's say MAC address of this switch is 0A. MAC address of this switch is 0B. MAC address of this switch is 0C. So when these switches will come up, switch 1 will share their BPDU to switch 2. Switch 2 will share their BPDU to switch 1 and switch 3. Switch 3 will also share their BPDU to switch 1 and switch 2. But when switch 2 and switch 3 will receive BPDU of switch 1, right, there will be bridge ID information. So switch 2 will came to know that bridge ID of switch 1 is lower than me. That means I am not root bridge. So switch 2 will stop forwarding BPDU. In the same way, switch 3, when switch 3 will receive BPDU of switch 1, it will see bridge ID of switch 1 is lower than me. That means I am not a root bridge. So this switch will also stop sending BPDU. So switch 2 and switch 3 will send BPDU only once, and after that switch 1 will be sending BPDU continuously after every 2 seconds. After every 2 seconds. Clear?
Java, Python, HTML, CSS.
So try to understand some terminology of a spanning tree protocol first. Like we are going to learn these all things: root bridge. Now hope it is clear to you what is root bridge. Then we are going to learn about BPDU. We are going to learn about STP cost. We are going to learn about root port. We are going to learn designated port. What happened? Okay. So root bridge is the switch who will have lowest bridge ID. BPDU is a message of a spanning tree protocol. And we will discuss about cost. First, try to understand port role. Guys, in a spanning tree protocol, a port will have two roles. Port can be DP, designated port. Port can be RP, root port, or port can be alternate. So port whose role is going to be root port will be in forwarding state. The port whose role is going to be designated port will be in forwarding state, and the port whose role is going to be alternate will be in blocking state. Okay. Now,
If you,
yes.
why are you taking three switches, for example, it's explaining the spanning tree? If you, why don't you take four switches connected together?
So why not 100 switches connected together?
No, four switches.
Why 4? Why not 100?
Why always three? They'll take three, for example, for
No, no.
explaining
Here,
this.
here we have 4 switches in this scenario. If I will
I think
design
for
a small topology, then only you will get concept. If I will design large topology, it will be complicated for you to understand how STP is a winding loop. Otherwise, we can connect 100 switches as well.
I think for that for creating that full mesh, at least we have the 3 point, na? I think
We,
for that, right?
brother, we can perform same thing by between two switches also by connecting two cable. Here also
Yeah.
a spanning tree will work like this topology.
Okay.
Okay. So root bridge is the switch who will have lowest bridge ID, and bridge ID is combination of two things: priority plus base MAC address. Bridge ID, priority, base MAC address. Priority is 2 bytes information. 2 bytes information means 16 bits. So range of priority can be 0 to 65535, and by default priority on switches is 32768. 32768. We can change priority. Let's say in this scenario, switch 1 will become root bridge, but what to I want that switch 2 should be my root bridge. Switch 2 should be my root bridge. So can I change base MAC address? No. Then how I will configure the topology so that switch 2 will become root bridge? Here I can configure lower priority. Here I can configure lower priority so that switch 2 should become root bridge. Now BPDU. So BPDU stands for Bridge Protocol Data Unit. Root bridge, see, always keep in mind this point. Root bridge always generate a hello message after every 2 seconds. That hello message is known as BPDU. It is used to elect root bridge. It is used to elect root bridge. Why all switches have generated BPDU and share to their neighbor switch to perform root bridge election? And there are two types of BPDU. One is TCN, another one is configuration BPDU. So now we are talking about configuration BPDU. We will talk about TCN BPDU later. Generally you will not see TCN BPDU. TCN stands for topology change notification. So whenever change will occur in the topology, then only we are going to use TCN BPDU. Okay, so we will discuss TCN BPDU later. Now we are talking about configuration BPDU. And when root bridge switch will generate BPDU, it will generate BPDU with cost 0. It will generate BPDU with cost 0. And when switch 2 will receive BPDU of root bridge of switch 1, it will add cost of their receiving interface. So let's say cost of this interface is 19. So cost is what is the cost to reach root bridge? So cost from switch 2 to reach root bridge is 19. So it is using cost of receiving interface. And when switch 2 will, let's say, will send BPDU of switch 1 to switch 3, switch 3 is also going to add their receiving cost, right? And switch 3 is receiving BPDU on this interface also. Here also it will add their interface cost. So now cost on this link to reach root bridge is 19, and cost to reach root bridge through this link is 38. So best path to reach root bridge is from this link, from this port, because from this port I am calculating least cost. So all non-root bridge switches will calculate cost to reach root bridge, right? And guys, as you know, STP never revealed formula to calculate cost, right? Formula to calculate cost. So it depends. Cost is inversely proportional to bandwidth. On fast Ethernet link we have different cost. On Ethernet link we have different cost. On serial link we have different cost. We will see this. Okay, so all non-root bridge switch is going to calculate cost to reach root bridge, and from the port switch will calculate least cost that will become best port to reach root bridge. That will become best port to reach root bridge. Now we need to understand STP port. STP port ID. Let me discuss first STP port ID. Again, STP port ID is combination of two things: priority plus interface ID. And by default priority is 128. So what will be port STP port ID of this interface? Let's say this is 0/1 interface. So STP port ID of this interface will be 128.1. Let's say this is 0/2 interface. So STP port ID of this interface will be 128.2. Again we can change this priority. Again we can change this priority. So let me discuss one topology here, that how BPDU is going to work and how switches is going to forward the BPDU. Let's say I have one switch here, switch 1.
Sir, what is the difference between this priority and bridge priority?
Bridge priority is used to elect root bridge, and this priority is used to reach root bridge.
For every VLAN
This
you
is
have one priority, or
interface
how?
priority, na?
Can
Not
you explain
VLAN.
this priority 128?
This is priority of interface, port priority.
For that priority is for the entire switch. This is for every port.
For STP enable port. Once we will enable a spanning tree protocol here, all switches will have one port ID. Right? And that port ID is combination of two things: priority plus interface ID. By default priority is going to be 128. So one interface whose port ID is, let's say, 0/1. So STP port ID will be 128.1.
What is the range for that? What value it will take maximum, that port priority?
Port priority maximum. Okay, I will check it. Wait, I will see. I will check it. What is the range? First, understand this topology, how BPDU is going to work here. Right? When I will perform practical, I will check what is the range of priority. I have three switch: switch 1, switch 2, and switch 3. Let's say this switch MAC address is 0A, this switch MAC address is 0B, and this switch MAC address is 0C. Suppose. So switch 1 will become root bridge in this scenario. So switch 1 will generate what? BPDU, configuration BPDU. Inside the BPDU there will be some information, like I am mentioning only important information. Inside the BPDU of switch 1 there will be root bridge ID, and root bridge ID will be what? 32768 plus MAC address 0A. Right? After that, cost will be there. As I told you, root bridge will always generate BPDU with cost 0. Then designated, or you can say sender, right? Designated bridge ID or sender bridge ID, both are same. Sender bridge ID. So this switch is root bridge. So root bridge ID and designated bridge ID means sender bridge ID, both is going to be same, right? Because This switch is sending this BPDU and this switch is generating this BPDU. This switch is root bridge. What happened here? This switch is root bridge. So in this BPDU designated port ID and root bridge ID both is going to be same. 32768 plus 0A. Right. After that, designated port ID will be there. Designated port ID. On designated port ID will be what? Let's say this is 0/1 interface. 0/1 interface. So designated port ID will be 128.128.1. Right. And switch 1 is going to send this BPDU to switch 2. Switch 2. Now switch is receiving this BPDU on, let's say, this interface 0/1 interface, and this is 0/2 interface, and again this is 0/1 interface, let's say. Okay, so switch 2 will receive BPDU of switch 1, and now switch 2 will calculate cost. Cost of receiving interface is 19. Cost of receiving interface is 19. See, switch 2 will relay this BPDU to switch 3. So inside the BPDU of switch 2, that switch 2 is going to relay to switch 3. Root bridge ID will be same. Root bridge ID will be same, 32768 plus 0A. Cost is going to be what? 19. Cost is going to be what? 19. Receiving interface cost 0 plus 19. 0 on root bridge, 19 on switch number 2. After that, designated bridge ID. Designated bridge ID means sender bridge ID. Bridge ID will be what? 32768 plus 0B, and designated port ID. Designated port ID. From which port it is going to forward this BPDU? From 0/2. So this port ID is going to be 128.2. Right? Switch 2 will forward this BPDU to switch number 3. And if switch 3 is connected with another switch, then switch 3 will change some information. Cost value, designated port ID, or designated bridge ID. Means sender bridge ID. Means on every switches, cost, designated bridge ID and designated port ID is going to be changed. But root bridge ID will be same. For switch number 2 also, who is root bridge? Switch 1, 32768 plus 0A. The switch whose bridge ID is 32768 plus 0A. But for switch 3, who is root bridge? 32768 plus 0A. And what is the cost to reach root bridge? 19 plus my receiving interface cost, 19, 38. And if switch 3 will send this BPDU to their neighbor, then designated bridge ID will be what? 32768 plus 0C. And designated port ID will be what? 128 dot ID of exit interface. ID of exit interface. So this is how switches is going to process BPDU. Okay. And guys, let's say switch 3 is connected with one switch here, and this switch is also sending one BPDU to switch 3. Switch 3 is receiving one BPDU from switch number 2, and let's say here we have one switch 4. Switch 4, right? So switch 4 will also send BPDU to switch number 3. Now switch 3 need to identify which BPDU is superior BPDU, which BPDU is best BPDU. So it will compare, right? It will compare both BPDU, and then switch 3 is going to decide which one is best. So how switch is going to identify superior BPDU? How switch is going to identify superior BPDU? First of all, it will check root bridge ID. Root bridge ID. Let's say switch 4 is sending one BPDU to switch 3 where root bridge ID is 32768 plus 0 D. So now on the basis of root bridge ID, switch 3 can decide which BPDU is superior BPDU. Which one is superior BPDU? Switch 3 is receiving superior BPDU from which port? From which switch? 2 or 4?
2 only.
2 only. But let's say in this BPDU also root bridge ID is same 32768 plus 0 A. Let's say switch 4 is connected with switch number 1. So switch 4 is forwarding BPDU like this. It is receiving BPDU from here, it is sending, right? So now switch 3 need to identify which BPDU is superior. For that, first it will compare what? Root bridge ID, and lower root bridge ID will be best. But if root bridge ID will tie, then switch is going to check what? Cost value. First root bridge ID, let me write here. First it will check root bridge ID. After, if root bridge ID will tie, then it will check what? Cost. So let's say cost in this BPDU is, cost which is coming from switch number 2 is 38, right? 19 plus 19, 90 of this interface, 90 of this interface, and cost which is coming in this BPDU is, let's say, 0, right? So cost of receiving interface is 19. Now on the basis of cost, switch 3 can identify which is superior BPDU, right? Here cost is 19, here cost is 38. So lower cost is best. That means I am receiving superior BPDU on this interface. But if cost is also same, like in this scenario, you can see cost will be also same, 19 of this interface and 19 of receiving interface. So from both sides, switch 3 is calculating what? Equal cost. So if cost will also tie, cost is tie in this scenario, then switch need to identify what? Superior BPDU. So switch will check what? Designated bridge ID. So now you tell me, switch 3 is receiving superior BPDU from which switch on the basis of designated bridge ID? In this, let's say MAC address of this switch is 0D. So designated bridge ID in this BPDU which switch 2 is forwarding is what? 32768 plus 0B, and the designated bridge ID of this BPDU is 32768 plus 0D. Which one is lower? This one. Which switch 3 is receiving from switch number 2? So again this is superior BPDU. But let's say I have topology like this, 2 switch 1 and switch 2. Let me design topology correctly here. If you understand this, that means you understand, 70% of a spanning tree protocol. 2 switch 1, switch 2. MAC address of switch 1 is, let's say, 0A, and MAC address of this switch is 0B. Which switch will become root bridge? Which switch will become root bridge?
Switch 1.
Switch 1. Now switch 1 is going to send BPDU from both interface, from this interface also, from this interface also. In this BPDU, which switch is forwarding from 0/1, what will be bridge ID? In this BPDU, what will be bridge ID? 32768 plus 0A. In this BPDU, what will be what will be bridge ID? 32768 plus 0A. Both are same. Now switch 2 cannot identify which BPDU is superior BPDU. Yes or no? Then switch will check what? Cost. Again cost from both sides is what? 19, 19. Cost is also tie. Then switch 2 is going to check what? Sender bridge ID, designated bridge ID. So designated bridge ID over here will be what? 32768 plus 0A. Here also 32768 plus 0A. Sender bridge ID is also same in this scenario. In upper scenario, sender bridge ID was different. But in this scenario, switch is receiving BPDU on 2 interface with same bridge ID, with same cost, with same designated bridge ID, means sender bridge ID. Then switch is going to check what? Then switch is going to check lower port ID. So port ID over here will be what? 128.1, and here port ID will be what? 128.2. So which one is superior BPDU?
Dot 1.
Upper one. But let's say I have not this topology. I have one switch here, switch 1. This switch is connected with one hub, let's say, just for example, right? And this hub is connected with another switch, switch 2, right? This switch MAC address is 0A, this switch MAC address is 0B. Now this time this interface is, let's say, 0/1. This time again switch 2 is receiving BPDU on 2 interface, on this interface and this interface. This is 0/1 and let's say this is 0/2. This time sender port ID will be also same, right? 128.1, 128.1. Then how switch 2 is going to identify which BPDU is superior BPDU? With the help of receiving port ID. So receiving port ID of this interface is 128.1, receiving STP port ID of this interface is 128.2. So upper port is best port. I am receiving superior BPDU on upper port. Is it clear, guys? Everyone? How switch is going to identify superior BPDU? How switch is going to identify superior BPDU? First of all, switch will compare bridge ID, then cost, then designated bridge ID or sender bridge ID, you can say. Then it is going to compare sender port ID. If sender port ID is also same, then it is going to compare receiving port ID, and receiving port ID can't be same up to interface, right? Now I want to tell you about STP port, like root port. Root port. So root port is the port which receives superior BPDU. Port which receives superior BPDU, designated port. Designated port is the port which sends superior BPDU, or you can say best BPDU. Receive best BPDU. Now guys, I am designing one topology here, and you need to tell me which switch will become root bridge, which port will become DP, which port will become RP, and which port is going to block. A port who is not going to become what? DP or RP, that port will become alternate, and a status of alternate will be blocking. So let's say I have again 3 switch, same topology. Switch 1, switch 2, switch 3. MAC address of this switch is 0A, MAC address of this switch is 0B, and MAC address of this switch is 0C. This is 0/1, this is 0/2, this is 0/1, this is 0/2, this is 0/1, and this is 0/2. Which switch will become root bridge? Which switch will become root bridge?
Switch 1.
Switch 1.
Switch 1 will become root bridge. So that means root bridge is going to send superior BPDU from this interface and this interface, right? Superior BPDU, because root bridge generates superior BPDU always. So these two port will become what? DP or RP? Designated port or root port? So as I told you, port,
Designated port.
yes, port which sends superior BPDU will become DP. So always keep in mind, all ports of root bridge will be always DP. All ports of root bridge will be always DP. Right? Now switch 2 is receiving BPDU on two interface, right? It will receive BPDU on this interface also and on this interface also. Switch 1 will also send BPDU, switch 3 will also send BPDU. Switch 2 will identify which I am receiving superior BPDU on which interface. First of all, it will compare what? Root bridge ID. So root bridge ID, the both BPDU will be same, 32768 plus 0 A. Then it will check what? Cost value. Cost over here is what? 19, and cost on this interface is what? 38, right? So this port is receiving superior BPDU, right? So this port will become what? This port will become what?
Root port.
Root port. This port is going to become RP. On all switches, you need to find RP port first, right? On all non-root bridge switch, you need to find RP port. And on a single switch, there can be not more than one RP. If there is more than one RP, that means there is loop, because RP is the port through that switch can reach to root bridge. RP is the port through which non-root bridge switch reach to root bridge. Because definitely switch is receiving superior BPDU on RP port, right? That means this port is the best port to reach root bridge. Now on switch number 3, which port will become RP? Because switch 3 is receiving BPDU over here also and here also. So which port will become RP?
I mean, 01.
01, because here it is receiving superior BPDU. So this port is going to become what? RP. And as I told you, on a single switch, there will be only one RP, right? There cannot be more than one RP on a single switch. And on one link, there can be not more than one DP. On this link, you can see one DP. On this link, you can see one DP, right? On this switch, we have only one RP. On this switch, we have only one RP. Now, this port and this port, right? See, this port can't be RP because RP is already available on these switches, right? So I need to find which port is sending superior BPDU. Now you tell me which switch is sending superior BPDU on this segment.
Switch 2 will be a designated port, and switch 3 will be a blocking port.
Why?
Because the MAC address will be higher.
See, when switch 2 will send BPDU on this link, root bridge ID will be 32768 plus 0A, right? Cost will be 19, and sender bridge ID will be designated bridge ID will be 32768 plus 0B. And when switch 3 will send BPDU on this segment, root bridge ID will be same 32768 plus 0A, cost will be same 19, and sender bridge ID means designated bridge ID will be 32768 plus 0C. Now who is sending superior BPDU? Switch number 2. So this port will become what? DP, and this port will become alternate, because on this switch we have already RP, and on a single segment there can be not more than 2 DP. So definitely this port will become what? Alternate. And a status of DP and RP will be in forwarding state, and the status of alternate port will be in blocking state. So as spanning tree protocol is going to block this link, STP will design this topology. Loop free topology. Clear to everyone?
Sir, if you have another link between switch 2 and switch 3.
We have another link between switch 2 and switch 3, okay? Yes?
How the ports are?
How the ports are? Let's say this is 0/3, this is 0/3. Now tell me again which switch is sending superior BPDU over here on this link? Switch 2. So this port will become DP, this port will become alternate. Okay. Now in this scenario, tell me which switch will become root bridge? Switch 1, root bridge switch. Means all port of this switch is going to be DP, 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 right? On switch number 2, which port will be RP? Because switch 2 is receiving, will receive on BPDU over here also, here also, and here also. It is receiving superior BPDU on which interface? Hello? These ports are
0 by
DP.
1.
0 by 1 on this port. No. That means, guys, you guys have not understood the concept. On switch number 2, which port will become RP? Tell me. Yes, Dhana. On R2, which port will become RP?
Switch to
Switch, which one you're asking? Switch to.
On switch number 2, which port will become RP? This is my question.
0/2.
0/2? No.
Except 0/2.
This is DP. All ports of root bridge.
Are DP only.
0 0.
DP. Now see, when switch 2 will receive BPDU on this link and this link, root bridge ID will be this one and center bridge ID will be this one, right? Cost will be same, 19 over here. On this link, BPDU root bridge ID is same, but cost will be what? 38. On this link also
Yes.
cost will be what? 38. So out of these two port, one port will become RP. For that,
0/0.
first switch will check what? Sender port ID. So sender port ID of this interface is lower than our link, right?
0.
So this port will become what? RP. Yes or no? And one
Yes.
DP is already there on the link. That means this port will become what? Alternate. Yes or no?
Yes.
On switch number 3, which port will become RP? It will receive BPDU here also and here also. Cost on this port is 19 and cost on this port is
Less.
38. That means this port will become what? RP.
RP.
On switch number 4, which port will become RP? This port, right?
Yes, yes,
Yes.
yes.
On this segment, which port will become DP? Which switch is sending superior BPDU on this link? Switch 3 is also sending BPDU. Switch 2 is also sending BPDU. Which switch is sending superior BPDU? Root bridge ID will be same, cost will be same, sender bridge ID. Sender bridge ID of switch 2 is lower than switch 3.
Lower.
That means switch 2 is
Switch
sending
2.
superior BPDU. So this port will become what? DP, and this port will alternate. Right? On this link, which switch is sending superior BPDU? Switch 2. So this port will become DP, this port will become what? Alternate. Clear? Now if you want to verify, I can verify you here. You can see, let me access these all switches. Switch 1 is root bridge switch, and see all ports of root bridge switch. So a spanning tree. All ports are designated port. Status is forwarding. Status is forwarding. These are Ethernet port, so cost is 100. For fast Ethernet link, cost is going to be 19. And these are the port priority. Here you can see. Right? So all port of root bridge are DP, status is forwarding. Right? Let me take you to switch number 2. Switch 2. Switch 3. And switch 4. Here you can see on switch number 2, enable, so a spanning tree, E0/0 RP, right? E0/0 is RP. Here you can see the topology. E0/1 alternate, correct? E0/2 designated port, E0/3 designated port, E1/1 designated port, correct? On switch number 3.
Can you explain that again, the diagram with all the port election like that?
Again.
Again.
Okay. Okay,
So
definitely. On switch number 3, first of all, see, verify it, guys, if anyone have, understood this. So a spanning tree protocol. 0/0 root port, 0/0 root port, 1/1 alternate port, and these are designated port, right? These are actually unused port here. So whatever ports is connected with end devices, that will be also what, designated port. Why? Because switch 3 is sending BPDU from this interface, right? So this port will become what, DP. It is sending superior BPDU from this interface, right? So this port will become always DP. On switch number 4 also we can verify it. So a spanning tree, which port is blocking, 0/0, you can see alternate, status is blocking, status of alternate port will be blocking, right? Cost is 100 because this is Ethernet link, priority is 128.1, right? And 1/1 is your RP root port over here, and rest ports are DP. These are LAN port, LAN users are connected on this port. I'm not using it now for now. Now if still you have, guys, question, let me design another topology here, right? And there I am going to perform now election. Let me
sir, recording is on.
no, don't worry. We are live on YouTube as well. We are live on YouTube as well, so you can use that video. I will share the link after class. Let's say here I have switch 1 and
Can you start the recording now?
no, why start the recording? I have already video, no? I'm already saving the class on YouTube.
No, actually he's saying today's class he will be broadcast on YouTube only directly, right, sir?
Yes.
Oh,
Yeah.
okay.
Okay, let's say this is my topology. Here we have 2 link. Here also we have 2 link. Here also we have 2 link. This is CCI lab exam topology. Okay. And let me connect these switches as well here like this. Let me make a bit complicated. I know not everyone can design loop free topology here, but guys, if you have understood the concept, you can design loop free topology. Switch 3, switch 4. Here MAC address is 0A. Here MAC address is 0B. Here MAC address is 0C. Here MAC address is 0D. Let's say this is my 0/1 interface. This is 0/2 interface. This is 0/3, 0/4, and 0/5. Here also this is 0/1, 0/2, 0/3, 0/4, 0/5, 0/1, 0/2, 3, 4, 5, Now, which switch will become root bridge?
Switch 1.
Switch 1.
Switch 1,
Which one?
root bridge. This port will become DP, DP,
DP.
DP,
DP.
DP,
DP.
DP. On non-root bridge switch, one port will become only RP, right? So on this switch, which port will become RP?
0 1.
This
0
port
slash 1.
RP, right? On this switch, which port will become RP?
0 slash 1.
No, 0 slash 1. Correct. This
Yes.
port. RP. On switch number 4,
0 3.
Yes. RP. Yes, directly connected.
RP, right? This port, already DP are there, so alternate,
Alternate.
right? Already DP are there, alternate,
Yes.
right? This port, DP, switch 2 is sending superior BPDU,
Yes. Yes.
DP.
alternate because RP is already there on the switch, and on single segment there can be not more than one DP. This port, which switch is sending superior BPDU on this segment? Switch 2. So this port will become what, DP? Yes or no? Hello guys.
Yes. Yes.
Yes.
Yes.
This port, alternate.
Alternate.
This port, DP, because switch 3 have
DP.
lower MAC address than switch 4, na? So DP,
DP.
DP,
DP.
alternate.
Alternate.
Now if here we have one user, here I have one user, IP address is 10.1, 10.2. If 10.1 want to communicate with 10.2, traffic will like this. Yes or no? Yes or
Yes.
no? If here is one user who is going to communicate with 10.1, this path. Yes or no?
Yes. Yes.
And guys, can I ask you one question here? Just one question. See, 10.1 and 10.2 are communicating by using this path. I want to use this path. How can I achieve it? How can I achieve it? Means
We have
I
to-
want this port should be RP. What I want, this port should be RP. So I can increase cost over here. If I will set cost 300 here, right? Now switch 4 will, receiving BPD over here also, here also, here also. Cost on this interface is 300 and cost on these two interfaces 100 and 100, 200, right? So out of these two interface, one interface is going to become RP now. Yes or no? So this port will become, RP, because it is sender port ID for on this link will be 0/4, means 128.4. So it is receiving superior BPD on this port now. This port will become RP. Now if 10.1 want to communicate with 10.2, which path will be in use? This path. Clear?
Yes, clear.
Dhana? Do you have still confusion?
Clear, sir.
Clear? You can design loop-free topology. You can manipulate the path by changing cost. You can manipulate the route bridge by changing the priority. So, this is my topology. If 10.1 want to communicate with 10.2, means PC1 want to communicate with PC2, which path will be used? Here? Yes? Yes or no? But if I want to use this path, I have to increase priority over here. Cost. sorry, not priority, cost. Cost over here, I can increase cost on this link. Guys, by default cost, wait. Cost on Ethernet link is by default 100. Cost on fast Ethernet link is 19, and cost on Giga Ethernet link is 4. Right, so you can see cost is inversely proportional to bandwidth, but we don't have formula to calculate cost. STP never reveal what formula they have used to calculate this cost. Only we can imagine that this is cost is inversely proportional to bandwidth. That's it. Otherwise we don't have any formula to calculate cost.
If we do a path manipulation means we have to go either we have to go cost or we have to do that priority also. How?
See,
If we do
first,
priority means what?
to identify superior BPDU, first switch check what root bridge ID, then switch check what cost. So you should use cost to manipulate path. For path manipulation we have cost. Or see what I can do, I can make this switch as root bridge. So if this switch will become root bridge, this port will become DP, this port will become DP, right? This port will become RP, this port will become RP, and on this switch which port will become RP? This port will become RP, right? That means my logical topology is going to be switch 1, 2, 3, 4. I have a connection like this, here we have one connection, and here I have one connection. Sorry, this port will be, this is DP, here, okay, this is not, here we don't have cable. This is my loop free topology now, right? If switch 1 is root bridge, then my logical topology is what? This port is RP, this port is RP, and on the here this port is RP. Now my logical topology is, here we have one link, here we have one link, and here we have one link. This is my logical topology, right?
Yes.
So if interviewer can ask you, like, you know, in this scenario switch 1 is root bridge, right, and you need to design this loop free topology, let's say, they can ask you any question. They can ask you like, I want to design this topology. So you can design this topology, right, by manipulating cost, by manipulating root bridge. Okay, so for now switch 1 is my root bridge. Here we are able to see, so a spanning tree protocol, this bridge is root, and because of that all ports of this switch is designated port. States is in forwarding. On switch number 2,
Change the cost on one link.
wait now. So a spanning tree protocol. See, there is two information, root bridge and bridge ID. Root bridge ID, this is information of root bridge, and this is information of this local switch. This is information of root bridge, and this is information of this local switch, right? So what is cost? 100. On Ethernet link cost is 100. Now I want to make this switch as a root bridge. So simply here I can do what? A spanning tree for VLAN, for let's say all VLAN, for VLAN 124094. For all VLAN I am going to change priority, because here we have multiple types of spanning tree protocol. Till now we discussed common spanning tree protocol, that is CST, common spanning tree protocol. But by default on Cisco switches PVST protocol is running, right? The difference between CST and PVST is CST is going to maintain one instances of STP for all VLAN, and PVST is going to maintain one instances for one VLAN. Means if we have 10 number of VLAN on switches is going to maintain 10 number of STP instances. So here for all VLAN I am going to set priority what? 0. So for all VLAN this switch will become what? Root bridge. So a spanning tree. Now it's saying this switch is root bridge. Now this switch is my root bridge. Right? So you can see bridge ID and designated bridge ID. Means sender bridge ID and root bridge ID. Both are same here. Right? Again I am going to remove this command. Again switch 1 will become root bridge. So a spanning tree. Wait for 2 seconds. Priority is 32768, and actually it have add VLAN ID, right? That's why we are able to see 9. Okay, don't worry about this. We will discuss it in PVST. Now you can see which switch is root bridge. This. So bridge ID of root bridge is 32678 plus this MAC address, and my bridge ID is 32768 plus this MAC address. Now in this scenario, switch 1 is my root bridge. Root bridge for all VLAN. For all VLAN, right? So logical topology is 1, 2, 3, 4. Right? So logical topology is we have one this port is RP, this port is here, this port is RP, right? And this port is RP. So we have one cable here, one cable here, one cable here, right? So what is my requirement? This should be loop free topology for VLAN 1 to 50, and for VLAN 51 to 100, my logical topology should be this one. Means switch 2 should be my root bridge. This one. This should be my topology for VLAN 51 to 100, and this should be my logical topology for VLAN 1 to 50. Can you achieve it? Yes, very simple. I will set priority 0 for VLAN 1 to 50 on switch number 2, and I will set priority 0 for VLAN 51 to 100 on switch number 2. So we can achieve load balancing as well. Now if VLAN 10 user will communicate with each other, right? They are going to use this path. When VLAN 51 to 100 user will communicate, they is going to use this path. When VLAN 1 to 50 user will communicate, they are going to use this path. Okay.
If any link, one link goes down, then
Okay, if see in this scenario, let's say for VLAN 1 to 50, this is my logical topology, right? If this link will goes down, guys, upper link will goes down, automatically this link will come in forwarding state. Yes or no? Now RP will, this port will become RP, because now switch 2 is receiving superior BPDU on this port. Now this port is not available. So again switch 2 is going to check. Now I am receiving superior BPDU on which interface? So this time I am receiving superior BPDU on 0/1. Sorry, 0/0. So 0/0 will become now RP. If this both port will goes down, right? Both link will goes down. Then switch 2 is receiving superior BPDU on this interface, right? This interface. So we will have this connection. Like this. Getting my point? Clear? On switch number 4, on switch number 4, do so spanning tree protocol. Which port is RP? 1/1. 1/1. But I want to receive traffic on this link, not on this link. So here I can increase priority. Here I can increase priority. Here priority is 100. Here priority is 200. Right, 100 of this interface and 100 of this interface. Total priority is 200. Right. So if I will set priority 300 over here, automatically 0/0 will become what? RP. Clear?
Can you set it and show it?
Now which port is RP? 0/0. And the status is in listening. Soon it will come in forwarding state. For that you have to understand STP state. In 30 seconds this port will come in forwarding state. But now you can see 0/0 is my RP. Because cost on E1/1 is now what? 300. Clear?
Clear, sir.
So you can perform, path manipulation also. You can achieve load balancing also, right? For some VLAN, switch 1 should be root bridge. For some other VLAN, switch 2 should be my root bridge. You can configure this type of scenario now. Okay, so tomorrow we will start from states of STP. Today we understood basic about spanning tree protocol, how loop can form in the topology, right? And how spanning tree protocol is going to work. How spanning tree protocol is going to work. How it will block the backup path.
So can you show how to do that load balancing for?
Yes. On switch number 1, let me do one thing. On switch number 1, config T, a spanning tree for VLAN, let's say 1 to 10. Priority is 0. On switch number 2, a spanning tree for VLAN 11 to 20. Priority 0. Now show a spanning tree protocol. Here I have to create VLAN 1 to VLAN 1 to 20, and on switch number 1 also VLAN. Now see, on switch number 1 I'm going to run command show a spanning tree protocol. So a spanning tree. So VLAN brief. We have these all VLAN. So a spanning tree. Still this switch is here. I am going to configure one link as trunk. Right? Let's say interface E1/1 switch port trunk encapsulation.1q and switch port mode trunk. On switch number 2 also interface E1/1 switch port trunk encapsulation.1q and switch port mode trunk. Now on switch number 1 you can run a spanning tree protocol command. So a spanning tree. See, this is STP instance for which VLAN? For VLAN 1. This switch is root bridge. For VLAN 2 also this switch is root bridge. But for VLAN 11, 6, 7, you can see for this VLAN this switch is root bridge. For VLAN 8 also, for VLAN 9 also, for VLAN 10 also, but for VLAN 11 you can see for VLAN 11 also this switch is root bridge. I think on switch number 2 I have set the priority 0 or not. So a spanning tree. This switch is not root bridge for VLAN. You will see correct output in 30 seconds. Wait. For VLAN 11 now this switch is root bridge. Over here also we can refresh the. Now we can check for VLAN 11. Link between switch 1 and switch 2 is working or not.
Think we have to create the trunk link on that E/0/0/0.
Link between switches will be trunk. All link will be trunk. Switch port trunk encapsulation dot 1q switch port mode trunk. So a spanning tree. For VLAN 1, this switch is not root bridge, right? This is MAC address of switch 1, right? MAC address of this switch is this one, right? For VLAN 2 also, this switch is not root bridge, but for VLAN 11, for VLAN 11, this switch is root bridge switch. So for VLAN 11, all ports of this switch is in forwarding state. For VLAN 10, this port is root port, this port is alternate port, and this port is designated port. On switch number 1, I should have same output. So a spanning tree. For VLAN 1, these all ports are designated port. Let me check for VLAN 11 now. Yes, now you can see. For VLAN 11, this switch is not root bridge. This port is RP, this port is alternate, this port is designated port, right? Now, this switch is root bridge for VLAN 11.
Yes, yes.
So,
That's
if
correct.
I will talk about topology, so we have two topology here, right? One for VLAN 1 to 10 and one VLAN 11 to 20. For VLAN 1 to 10, switch 1 is my root bridge. So my logical topology is, here we have one cable, here we have one cable, and here we have one cable, right?
Yes, yes.
And for VLAN 11 to 20, switch 2, switch
Is
1,
the root bridge.
3, 4. This is my topology. Right. So let's say here we have one user. Here we have one user. And here we have one user. So if these two users want to communicate, they will communicate like this. If this, here we have one user, here we have one user. This user will communicate like this. Let's say this user, and here we have one more user in VLAN 20, this user in VLAN 10, this user is in VLAN 20, this user is in VLAN 10, this user is in VLAN 20. So when PC1, this PC and this PC will communicate with each other, they will communicate by using this link. When this PC and this PC will communicate, they will communicate by using this link. Clear?
Yes, yes. Thank you.
Right. So tomorrow first we will discuss state of STP, then we will start types of, no, first we will discuss topology change. What will happen when change will occur in the topology? Let's say here I am going to add one switch. Here I am going to connect one switch, right? Switch. MAC address of this switch is, let's say, 0D or 0A. So this switch will think what I am root bridge. It will send their BPDU to switch number 2. When switch number 2 will receive BPDU of this switch, switch 2 will came to know that this is inferior BPDU, not superior BPDU. Switch 2 will send the superior BPDU to this switch, that you are not root bridge. Take the BPDU of root bridge, right, via me. Again, it will calculate cost, and it will start maintaining new table. In that table, switch 1 will be the root bridge. So whenever change will occur, right, how STP, or whenever, let's say now this link is in forwarding state, this link is in forwarding state, and this link is in forwarding state. Let's say when this link will goes down, then how STP will converge the topology? If this link will goes down, then this link should be come in forwarding state. So we have to understand how topology will converge whenever change will occur. So whenever change will occur, there is another BPDU, guys, TCN BPDU. TCN BPDU, topology change notification BPDU. So whenever a port of a switch will goes down of non-root bridge switch will generate TCN BPDU to inform root bridge, brother, there is some change in topology. Please reconvert the topology, right? And generally STP takes 30 seconds to convert the topology. That's why in packet tracer, link was not green for 30 seconds. Actually, STP was converging the topology. So we will discuss in states how many states are there, like disable. We have some state disable. This is like OSPF neighborship state, blocking, then listening, then learning, and then forwarding. So you can check it on any switch. If I will down one interface, let's say on switch number 2 or on switch number 3, which port is RP? This port is RP. So if this port will goes down 0/0, 1/1 will become RP, this port will become RP, right? So let me down the interface, this interface is 0/0 and say shut down. And now check a spanning tree. So see, this port state is now in listening. In listening it will spend 15 seconds. After that state will come to learning. In learning also it will spend 15 seconds. See, state is still in listening. Now it is in learning state, and after 15 seconds it will come in forwarding state. So total time is 30 seconds, right? Switch is taking. So for 30 seconds user cannot communicate. Now you can see this is forwarding state. So for whenever change will occur in the topology, right? When this link will goes down, my RP will goes down, right? This port will become RP, but this port will take 30 seconds to come in forwarding state. That means for 30 seconds PCs cannot communicate with each other. Yes or no? Okay, so we will reduce this time also. Let's continue tomorrow from STP states. Okay, topic for tomorrow is STP state, then topology change. If now
Sir,
you have any question, you can ask. Yes.
if you bring a switch with the lower MAC,
then that switch will become root bridge.
that will become a root bridge, right?
Right.
Already one root bridge will be there, right?
So this switch will not be root bridge. Then if I will connect one more switch with lower priority or lower MAC address, then this switch will become root bridge.
But if you want the older switch should be root,
yeah,
this should not.
We have multiple features for that. We will enable that features, right? That this switch should be always root bridge. Otherwise, the attacker will come with their switch with priority 0 and they will connect, and that switch will become root bridge, right? So we have some, guard. We have some guard. We will discuss it later.
Okay.
For now, if you will connect new switch with lower MAC address, then that switch will become root bridge for now. Okay.